All right, we're in section 5.6 where we're going to be using the multiplicative property to solve equations. So we talked about reciprocals in 5.5, and when we use the word reciprocal, basically we were talking about flipping the fraction. And what that meant was whatever value was in the numerator, we were going to place that in the denominator, and whatever value was in the denominator was going to be placed in the numerator. So that's what we're going to look at first today. Looking at these numbers here in the chart, we have 3, we have 3/4, and we have 4 2/3. So in order to find the reciprocal of these numbers, the first two seem pretty straightforward. You just flip the fraction around because 3 can be written as a fraction of 3 over 1, so 1/3 is our reciprocal. Okay, for 3/4, it's again flipped around, so now it's just 4/3. For 4 2/3, you got to make that into an improper fraction, which is 14/3, which means that my reciprocal is 3 over 14. So now, also looking at what we did when it came to multiplying fractions, if we were to multiply these values to the reciprocal, we would get a product of 1. So 3 times it by 1/3 would equal 1. Same thing goes here. 3/4 times by 4/3 would equal 1. And then 14/3 times it by 3 over 14 would equal 1. So what we have is a rule. And that rule is that multiplicative inverse property means that if you have the product of a number and its multiplicative inverse, the result will be 1. So the example that they have here uh, on the notes, 3/5 times by 5/3, which are reciprocals of each other, equal 1. The reason why we can also say that is we can cancel these out. 3 divided by 3 is 1. 3 divided by 3 is 1. 5 divided by 5 would also be 1. And 1 times 1 is 1. 1 times 1 is 1. So the main thing that we're going to look at is why is this property useful for solving equations? Well, before, all we knew was the inverse property for either multiplication or division to try to get a result of 1. Because what we would do before is we'd multiply 4 here, multiply 4 here, get this to cancel. Then we'd have 3x is equal to 9 times 4, which is 36. Divide that by 3. When you divide that by 3, x would equal 12. Okay, so that's kind of how we'd had to solve it before. But now we know that uh, we can multiply both sides by the reciprocal of that coefficient. We can say, all right, well, I can just multiply this by 4/3. Cancel, cancel, which will give us x. This is over 1, and then we can go about multiplying the fraction like we did in previous sections. We know that 9s are divisible, both divisible by 3, so 9 divided by 3 is 3, 3 divided by 3 is 1. Multiply it across, 3 times 4 is 12. You get the same answer. Okay, so it doesn't matter if you go about using the first step where you multiply everything first and then divide it, or you just multiply it by the reciprocal, you get the same answer. So for the first part here, you know, I'm going to be more inclined to use the multiplicative inverse. So let's go about solving that. Let's try to get good at solving it those ways. So here we know that the reciprocal of 5 over 6 is 6 over 5. So write that in. Those cancel, those cancel. So now I have m is equal to 20 over 1, essentially, times it by 6 over 5. I know that 20 and 5 are both divisible by 5. This turns into 1. This turns into 4. 4 times by 6 is 24. If we look at the next example, 3/4 n minus 20 is equal to negative 16. All right, we have to do the the inverse operation of addition or subtraction. So in this case, I got to add 20 to both sides. All right, that doesn't change. I got to cancel that out. So now I have 3/4 n is equal to negative 16 plus 20, and that's 4. Okay, so now multiplying these things by its reciprocal, 3/4, reciprocal is 4/3, so I got to do the same thing over to this side, cancel, cancel. I got n is equal to 4 over 1 times by 4/3. There's nothing I can cancel, so it's immediately multiplied across. 4 times 4 is 16, and 1 times 3 is 3. If you left it like that, great. If you want to write it as a mixed number, it would be 5. This would be 3, 15. So either 16/3 or 5 and 1/3. All right, so again, trying some on our own. I'll actually look at a couple of examples here. Let's look at this one right here. So again, we're going to subtract 7 to both sides. I got 4 over 9x is equal to 31 minus 7, which is 24. And now I have a fraction here, so I'm going to multiply it by its reciprocal, which is 9 over 4. Cancel, cancel. X is going to equal, so I got 24 over 1 times it by 9 over 4. I know that 24 and 4 are both divisible by 4. So this turns into 1, this turns into 6, and 6 times 9 is 54. Okay. The, the last two here are ones that are a little bit more complex. Why? Because we have fractions in each one of the terms of the equation. So what our main goal is to possibly try to eliminate as much fractions as we can from these particular terms. So actually, the first one that we're going to look at is actually this one right here. The reason why this one seems to be a bit easier to solve than the one on the left is you have common denominator. They all have 17 in the denominator. We can use that to our advantage when we're talking about equations. So what we're going to do is we're going to kind of incorporate the distributive property here, and we are going to multiply the entire equation by 17. What that'll do is it'll eliminate the 17s in each one of the denominators. So 17 times by 11 over 17 will just be 11. It eliminates that denominator. Minus 17 times 5 over 17x will just be 5x. And then it's going to be equal to 17 times by negative 8 over 17. Well, that'll just be negative 8. So by multiplying the whole thing by 17, actually we eliminated every single uh, fraction. Okay, it's not always going to be the case. Like in the next example we're going to do won't be, but uh, you can for the majority of them. So now you can just go about solving like we did in previous chapters, subtracting 11 to both sides. Now I have negative 5x is equal to negative 8 minus 11, which is negative 19. Dividing negative 5 to both sides, I get x is equal to positive 19 over 5. And if you wanted to write that as a mixed number, it would be 3, 5, so 3 and 4/5. Okay, so that's what made that one a bit easier because you had all the same denominators. Now, if we look at this one here, uh, we have different denominators. We have 15, 9, and 5. So you have to choose a value to distribute that's the least common uh, least common multiple of those values in the denominator between 15, 9, and 5. So you could multiply them all together and get a value, but I believe, let's see, I think 45 is going to be our value because uh, 15 goes into 45 three times, 9 goes into 45 um, 5 times, and 45 goes into 5 uh, 9 times. So I'm going to multiply everything here by 45. So 45 times it by 13 is 585 divided by 15 equals 39. So now I have, for my first term right here, I have a value of 39x minus 45 times 7 divided by 9 gives me 35. And then finally, I have negative 1 times by 45. Negative 45 divided by 5 is negative 9. So this is a situation, again, where we were able to eliminate our fractions by multiplying it by the least common multiple. So negative 9 is going to be added to 35 here. And I get, what, 26? And I'm left with 39x dividing 39 to both sides. I get x equals 26 divided by 39. But that can be reduced because both of them are divisible by the largest number is 13, because 26 divided by 13 is 2, and 39 divided by 13 is 3. So x would equal 2/3. All right, and that is being able to multiply using multiplicative inverses. Hopes helps. Until next time.